Before there were names for things, before there were eyes to see them, there was motion, not silence, not stillness. Motion, a cloud stretched across the dark, thin, cold, endless, hydrogen and dust drifting through a quiet that had never known sound. It did not know it was a cloud. It did not know it was vast. It simply was. And it moved. No part of it moved quite the same way as another. One region slid slightly northward, another dipped south. Some swirled lazily, some pulsed from ancient shock waves left behind by long-dead stars, tiny differences, barely measurable. But they were there, and gravity was there too. Gravity did not shout. It did not command. It simply pulled. Where the cloud was slightly denser, gravity tugged a little harder. More gas drifted inward. The region thickened. Its pull strengthened. A slow feedback began. Not dramatic, not sudden, just inevitable. Across millions of years, the cloud began to contract. As it drew inward, the drifting motions did not vanish, they tangled. Opposites canceled each other out in places, left meeting right, up meeting down. But not perfectly. There was always something left over, a trace of imbalance, a whisper of spin. The entire cloud, without knowing it, had begun to rotate. At first, the rotation was almost meaningless. If you had been there, if there had been an eye to witness it, you would have seen nothing but a slow collapse. But as gravity pulled the cloud tighter, something changed. The radius shrank, and the spin increased. Like a skater drawing in her arms, the cloud's rotation accelerated. What had been a faint drift became a measurable turn. The turn became a sweep. The sweep became a whirl. The cloud flattened material that once floated in all directions began settling into a plane. Gas compressed along the axis of rotation and spread outward along the equator of its motion. What had once been a sphere softened into a disk. A vast spinning disk of gas and dust, glowing faintly from the friction of its own collapse. At the center, pressure mounted. Atoms collided more frequently. Temperatures climbed, density soared. The heart of the disk grew hotter, brighter, more violent. Hydrogen nuclei slammed together under crushing weight, and then fusion ignited. Light burst outward. A star was born. It did not burst into existence with a scream. It bloomed, a steady ignition. A core reaching millions of degrees. A sphere of plasma held in balance between gravity pulling inward and radiation pushing outward. It spun. It had to spin. The motion of the original cloud had nowhere to go. Around it, the disk remained, thinner now, brighter, a swirling river of dust and gas, encircling the newborn star. Every grain within it already carried sideways motion. Every particle already knew how to orbit. Collisions began. Dust met dust, clung. Pebbles collided into rocks. Rocks merged into boulders. Each impact was gentle enough to build rather than shatter. Over millions of years, clumps grew large enough to exert gravity of their own planetesimals. They tugged on neighboring debris, sweeping clear lanes through the disk. They collided, merged, fractured, reformed. The disk became a battleground of creation. And through it all, everything moved in the same direction, not by choice, by inheritance. The star's spin dictated the disk spin. The disk spin dictated the motion of every forming world. One planet grew closer to the star, small and rocky. Another formed slightly farther out. Then another, some massive, gathering thick envelopes of gas. Some compact and dense, all circling, all falling toward the star and missing. A system emerged, not chaos, not collision. Structure, the sideways motion saved them. Each planet was perpetually falling inward under gravity's pull, but each also carried enough forward speed that its path curved around the star rather than into it. Their trajectories were not perfect circles. They were ellipses, subtle ovals, but stable, repeating. They would continue for billions of years. Far from the star, beyond the realm where rock dominated, giants swelled. Gas planets with swirling storms and metallic cores. Around some of them, smaller disks formed miniature versions of the original. Moons were born the same way planets had been, orbiting worlds around orbiting worlds, and the system settled into rhythm, a steady turning, a clock with no ticking sound. Elsewhere, in the galaxy, similar clouds collapsed, some larger, some smaller, all with some whisper of initial motion, all amplifying that motion as they shrank. The galaxy itself had formed the same way long before. An enormous cloud, unimaginably vast, had collapsed under its own gravity. It too had possessed a faint net rotation. It too had flattened into a disk. Hundreds of billions of stars had ignited within that rotating structure. They orbited the galactic center in great sweeping arcs. No part of the universe had ever been perfectly still, and so nothing that formed from it could be still either. On one of the inner planets, oceans formed. The world cooled enough for water vapor to condense. Clouds gathered. Rain fell. Seas pooled in low basins. Continents shifted slowly atop molten rock. The planet spun once every 24 hours, its rotation inherited from countless collisions during its formation. It did not spin because something forced it to. It spun because it had never stopped. Above it, a moon circled. The moon had been born in violence. Early in the planet's history, another world had struck it. A glancing blow, catastrophic, rock vaporized. Debris blasted into orbit. For a time, a glowing ring of molten fragments encircled the planet. From that ring, the moon coalesced. It too carried sideways motion. It too was falling toward the planet constantly. But its forward velocity bent its path into a stable curve. It was perpetually missing the world beneath it. Tides rose and fell as gravity tugged between them. Over billions of years, the moon drifted slowly outward, inches per year, trading rotational energy from the planet for orbital distance. But the dance remained stable. The planet circled its star at nearly 67,000 miles per h-hour. No sensation of speed betrayed the motion. Everything on the surface moved with it. Oceans, mountains, atmosphere. There was no friction to slow it in the vacuum of space. No resistance. Motion persisted. Within the atmosphere, rotation shaped weather. Air near the equator moved faster than air near the poles because the planet's circumference was widest there. When warm air rose from heated oceans and drifted north or south, it carried that momentum with it. The ground beneath moved at a different speed. The mismatch deflected the wind. Storm systems began to rotate. A tropical depression gathered heat from warm water. Rising air created low pressure. Surrounding air rushed inward. The planet's spin twisted, that inflow into a spiral. A hurricane was born. From space, it resembled a miniature galaxy, a spiral arm of clouds curving around a calm central eye. It spun because the planet spun, because conservation of angular momentum demanded it, because motion does not simply disappear. Overland, in the heart of a thunderstorm, winds at different altitudes sheared past one another. A horizontal roll of air formed, invisible and unstable. When a powerful updraft tilted that roll vertical, it tightened. As the column narrowed, it spun faster. A tornado descended, a violent funnel of condensed vapor, wind screaming past 200 miles. Per h-hour, the same principle governed it as governed moons and planets. Collapse plus rotation equals acceleration. In a bathtub, water draining through a central hole curved into a whirlpool. The scale was small, the physics identical across the solar system. Each planet spun at its own rate. One rotated once in 10 hours, flattening at the poles from centrifugal force. Another turned slowly, retrograde, perhaps flipped long ago by a colossal collision. One lay nearly on its side. Seasons extreme and strange, all bore scars of impacts, because orbits were stable, but not isolated. Asteroids drifted. Comets followed elongated paths, plunging inward from distant reservoirs of ice before arcing back into the dark. Occasionally, trajectories intersected. Collisions reshaped surfaces, altered tilts, changed rotation speeds. But rarely did gravity alone cause catastrophe. A planet did not simply spiral into its star because there was no friction to steal its momentum. Its sideways motion remained. Balance held. In the vacuum between worlds, there was almost nothing. A few stray atoms per cubic centimeter, not enough to matter. Energy remained conserved. The star itself rotated once every few weeks. Its equator turned faster than its poles, a differential spin that twisted magnetic field lines into loops and flares. Plasma arched outward in luminous storms. Dark sunspots marked tangled magnetic knots. Even the star's spin traced back to the original collapsing cloud. Nothing had started from zero in distant regions of the galaxy. Other stars circled the galactic center. They did not move in perfect unison. Each followed its own orbit, some slightly elliptical, some inclined. But overall, the disk rotated coherently, 200 million years for one revolution. Since the solar system formed, it had completed roughly 20 such galactic orbits, each time returning to a similar region of space, though the galaxy itself slowly evolved. Spiral arms were not rigid structures. They were density waves, traffic jams of stars and gas moving through the disk. Stars passed in and out of them, like cars merging onto a crowded highway. Rotation shaped everything. Without it, gravity would have crushed matter inward without forming disks. No planets, no stable surfaces, no long-lived climates. Just spheres collapsing into tighter spheres. Instead, sideways motion transformed collapse into orbit. It prevented total destruction and allowed complexity to emerge. On the spinning blue planet, life appeared. It did not know it was riding a rotating sphere circling a star, orbiting a galactic core. It did not feel the 500,000 miles per hour of galactic motion. It sensed only local winds, the rhythm of day and night, the steady arc of seasons. But those rhythms existed because of spin. The tilt of the planet's axis, likely set by ancient collisions, created seasons as it orbited its star. Without rotation, there would be no day. Without orbit, no year. Time itself was measured by motion. The moon's pole stabilized the planet's axial tilt, preventing wild swings that could have destabilized climate. The system was not static, but it was steady enough, all because of the delicate balance between falling and missing. Far beyond the visible stars, dark matter shaped the galaxy's rotation. Invisible halos of mass held outer stars in orbit faster than visible matter alone could explain. The galaxy's spin was not uniform. Inner regions turned more quickly, outer regions more slowly, yet gravity bound them together. On even grander scales, galaxies orbited within clusters. Clusters drifted within filaments of the cosmic web, vast strands of matter stretching across hundreds of millions of light years. The universe expanded overall, space itself stretching. But locally, gravity wove rotating systems from slight initial irregularities in density. The early universe had not been perfectly smooth. Tiny fluctuations, 1 part in 100,000, seeded everything. Where matter was slightly denser, gravity gained leverage. Clouds collapsed, rotation amplified. Stars ignited, galaxies spun. The pattern repeated across time and distance. In one spiral galaxy, billions of years after its formation, intelligent beings looked up. They charted the sky, noticed the planets wandering against the background stars, noticed the predictable paths. They imagined circles first, then ellipses. They asked why the moon did not fall. Eventually, they understood that it was falling. They calculated velocity, measured gravitational acceleration, derived equations that describe the curvature of space-time itself. They launched satellites, artificial moons, giving them just enough sideways speed to miss the planet endlessly. Their spacecraft circled the world, circled the moon, circled the sun. They learned that to escape gravity entirely, they needed more speed, not upward, but sideways, enough that their path would never curve back. Rockets roared, probes drifted outward, yet even those probes remained bound to the galaxy orbiting its center along with their star. There was no true stillness. On their planet, the beings watched storms from orbit. They saw hurricanes spiral. They mapped jet streams curving with planetary rotation. They dropped water down drains and noticed direction mattered depending on hemisphere. They built particle accelerators, spinning subatomic particles at near light speed in circular tracks. Magnetic fields bent trajectories. Even at microscopic scales, motion curved under force. They recognized the rule everywhere. Angular momentum was conserved. When ice skaters pulled in their arms, they spun faster. When collapsing stars exhausted nuclear fuel and gravity overwhelmed pressure, they shrank catastrophically. If massive enough, they formed neutron stars, objects only miles wide but rotating dozens or hundreds of times per second. Some spun so rapidly they emitted beams of radiation like cosmic lighthouses, pulsars, ticking precisely as they rotated. In extreme cases, collapse formed black holes. If the original star had rotated, and it always had, the black hole inherited that spin. It dragged space-time itself into a whirl around its event horizon. Even gravity could not erase rotation. Across cosmic time, collisions between galaxies occurred. When two spirals merged, their orderly disks were disrupted. Stars flung into new orbits. Gas clouds collided and ignited bursts of star formation. The resulting galaxy might appear elliptical, less structured, but within its stars still moved, still orbited a shared center of mass. Motion reorganized. It did not disappear. The beings on the small blue planet considered what would happen if sideways motion vanished. If a planet suddenly stopped moving along its orbit, it would fall straight into its star. If the moon stopped its sideways drift, it would crash into the planet. If the planet stopped spinning, one side would face the star constantly, the other in eternal night. Atmospheric circulation would collapse into extremes, but nothing simply stops in a vacuum. Energy must go somewhere. Without friction, without resistance, motion continues. Over immense timescales, small perturbations accumulate. Gravitational tugs from other planets shift orbits subtly. Stars pass near one another, nudging trajectories. Galaxies interact, altering spin, yet the principle holds. Initial motion, amplified by collapse, structured by gravity, preserved by conservation laws. In the far future, the star at the center of the solar system will exhaust its hydrogen. It will swell into a red giant, perhaps engulfing inner planets. It will shed outer layers into space, leaving behind a dense white dwarf. That remnant will still rotate. Planets that survive will adjust their orbits to the star's reduced mass, drifting outward but continuing to circle. Even in death, spin persists. Eventually, galaxies themselves may merge into larger structures. On timescales beyond imagination, stars will burn out. Black holes will dominate. Yet even black holes will orbit one another, spiraling inward as they radiate gravitational waves, merging into larger rotating singularities, spin upon spin, all tracing back to slight asymmetries in an early expanding universe. On the small planet, night falls. The rotation of the world turns a continent away from its star. Cities glow along coastlines. The moon rises, reflecting sunlight. It moves steadily eastward, tracing its curved path. No one feels the planet hurtling around the star. No one senses the star racing around the galaxy. The motions are constant, smooth, uninterrupted. The beings sleep on a spinning sphere. They wake on a spinning sphere. They measure time by its rotation. The galaxy above them arcs across the sky. A faint band of light, billions of stars turning together. Somewhere within that band, gas clouds are collapsing right now, flattening into disks, igniting new suns. New planets are forming. New moons beginning their endless fall and misdance. Somewhere, perhaps, oceans will gather, atmospheres will swirl, storms will spin. And maybe, after enough orbits, life will look upward and ask why everything moves in circles. The answer will be the same, because nothing began perfectly still, because gravity pulls inward, because motion sideways bends falling into orbit, because as matter collapses, it spins faster, because angular momentum does not simply vanish. The universe did not decide to spin, it inherited spin. And once in motion, it kept moving. From the smallest whirl of draining water to the sweep of galaxies across cosmic time, the pattern repeats: collapse, rotation, balance. A perpetual choreography of falling and missing, a dance without friction, a structure born from motion that never truly stops. And so everything turns, not by command, by consequence.